So continuing our adventures in graphing linear equations, in this case though, most of these, I believe all of these actually are in standard form, so we're going to have to convert them to slope-intercept form. So practicing getting y by itself while putting it onto a graph. So we have 2x minus y equals 3. We're going to identify our y, which has that negative in front of it, so that's at negative 1y. For some of you, it's easier if you put a 1 there. Our line of great divide. And remember, step 1 is move your x value, so get it to the other side. It's the positive 2x, so we're going to subtract 2x from both sides. And that's going to leave us with a negative y. Make sure I'm going to put a negative 1. Negative 2x plus 3. That negative 1 can't stay there. We got to get y completely by itself. So we're going to divide everything by negative 1, each term by negative 1. And so y will equal that negative 2 divided by negative 1 is going to make it a positive 2x. Positive 3 divided by negative 1 will give you negative 3. Okay, so now we know that our m, so y equals mx, is 2. Imaginary 1 when we start discussing rise over run. And our b value is at negative 3. So we're going to go down to negative 3, and then we're going to go up 2 over 1, up 2 over 1, and fill in our entire graph. And then we can come down to the left 1 because negative and negative give us that positive. So going down is negative, left is negative as well. And that double negative gives you that positive. And this line is increasing when going to the right. So head it up. And as soon as you see that positive slope, we know that that line needs to go that direction. All right, so number 8. If you think you're pretty comfortable, go ahead and pause the video and try this guy and see how you do. Like I've said 100 times before, if you mess up, that's part of the game. You got to mess up to find out what your brain's going to do to you to send you down the wrong rabbit hole first. If you only copy the notes, you won't catch your mistakes before they start happening when it matters. So again, identify where your y is. What's in front of it is a conversation. What's the coefficient with your y? And then move x. So move x is second. We're going to do subtract 2 because it's a positive 2. So I have 4y equals negative 2x plus 8. Then we're going to divide by the coefficient of y, whatever's in the front. So divide by 4. Each term gets a 4. So y equals a negative 2 over 4. So we can leave that as is for now. And then 8 over 4, remember 8 divided by 4 is going to give us a positive 2. But ideally, we're in high school, so when we start doing what is our slope, negative 2 over 4 is not where we want to stay because we know 4 is divisible by 2, so it's going to be a negative 1/2 slope. And then our y-intercept starting point or constant in this equation is that positive 2. So we're going to go to our positive 2. We know our slope is negative, so we know our line is going to head in the direction of down when reading from left to right, so it's going to go down. So if we went down 2 and over 4, that will get us where we need to be, but our reduced version is down 1 over 2, which is right there in the middle of it. It's just going to help us keep our line straight. So up 1 over 2, up 1 over 2, again, to finish out your line as far as possible in both directions. And then we can connect our dots. It is decreasing. It's going down to the left. Put an arrow on each end because it goes infinitely. We're just taking a little snippet of our line in our picture here. And that guy is done. So number 9, again, it's not in y equals mx plus b form. So we're shooting to put it in slope-intercept form. So this is our standard form. And actually, I'm telling you a complete story. There's not a y in this one at all. So we need to get x by itself. We need the variable by itself. So I'm going to move that 1. That's going to be x equals a negative 6. So this is back to our Hoy-Vux conversation. So no y was even present. So hopefully when you know that your assignment is to graph it, as soon as you see an x by itself, that's going to be a vertical line. So that's going to be our Vux. That means this line is going to go this way. Has an undefined slope, and it's an x equals equation. In this case, it's x equals negative 6. So we're going to go on our x-axis. 1, 2, 3, 4, 5. Oh, that's terrible. Negative 6. Vertical line. You jump straight off that graph. So if this happened to be your TI 83 or 84, you would maybe, it is a 10 by 10 window by standard, but you might have to sometimes change your window to find your graph. Like in this case, if this was your calculator, it would be a negative 5 to positive 5 window. So negative 5 being right here, positive 5, and then same for your y. And so if that was what your window was set on your calculator, you would not see this equation. So number 10, we're going to get y by itself. So 3x minus 5y equals 10. Again, we're going to identify our y. Put our line of great divide, so we know every time we cross it, we have to do the opposite. We're going to move x. It's 3x, and it's positive, so we're going to subtract to move it. So we have negative 5y equals a negative 3x plus 10. Whoops, and I'm falling off the screen, sorry. And then we're going to divide by whatever's in front of the y. And that's going to give me a positive y equals negative, and negative means it's going to turn into a positive 3 over 5x. And then 10 divided by 5, hopefully we do know, is 2. And that's a negative 5, so it's going to be a negative 2. So then our slope, or our m value, is going to be 3 over 5, rise of 3, run of 5. Our y-intercept starting point, or constant in this equation, is going to be a negative 2. So we're going to go to negative 2. It's a positive slope, which means the line is going to go in the up direction when reading from left to right. I'm going to go up 3, 1, 2, 3, and over 5, 1, 2, 3, 4, 5. And we have just graphed our line. We'll see if we can go the other way. Down 3, 1, 2, 3, 4, 5. And that works. And again, so you just grab something if you want to make sure the line is super straight and trace it as well. Anything you got that's a straight line will work. So you can use the edge of a piece of scratch paper. You can use a Post-it note. You can use all kinds of good things, whatever you got. But we want to make sure that line is as straight as possible. And we're connecting those dots. 2 more, hang in there. So 3x plus 2. And as I say, hang in there. Do that and or challenge yourself. Pause your video and go try those last 2 and then come back and check in with me. Again, I can't say it enough. Might as well mess up now. You're not going to lose anything. So it's identify your y, line of great divide, move x. So move x. And we have 2y equals negative 3x plus 7, because that 7 was positive. So we're going to divide both sides now by 2, because that's what's in front of the y. So y equals a negative 3 over 2x. 7 over 2 is going to be a nasty number, so it's going to be 3.5. You do want your starting point to be a decimal, not a fraction, because I think I discussed it last class. If I asked you to go find 7 over 2 on a number line, not that you can't do it, but you're going to probably mentally actually put it in this form anyway. So let's just go there. So our y-intercept is going to be a positive 3.5. 1, 2, 3.5. And then it goes down 3 and over 2. So I'm going to go 1, 2, 3. And notice I'm going in the halves, right? And then over 2. 1, 2. So down 3. 1, 2, 3. And over 2. And then we're off our page at that point, because otherwise we'd go down 3 and over 2, which is this way. And then we're going to connect our dots, draw our line. It is a negative slope, so that's why it's going down to the left and up to the right. But when reading from left to right, down to the right, up to the left, when we're reading from left to right, as you would read like a sentence, it is going down because of that negative slope. So our slope was negative 3 over 2. Our y-intercept, or b value, was 3.5 positive, which is why we started in between 3 and 4. And then we just counted down. All right, so we have another messy one. So 3x minus 1/2 y equals 2. So we're going to identify our y and what's in front of it. Draw our line of great divide so we know when anything crosses, we do the opposite. So we're still working with 3x, so we're going to subtract 3x, and that is completely coincidental. But so we're moving x. So identify your y. Move x. Then multiply, divide, whatever you need to do to get whatever's on your y off. Now, negative 1/2, the inverse of dividing by 2, which is this negative 1/2 is division of 2, and a negative 2 in that case. So the opposite would be multiplying. So if I multiply this side by a negative 2, and I multiply this side by a negative 2, and I'm going to move it down where we have more space. So negative 2 times the negative 3x plus 2. Then we will have y by itself. So y, this is going to cancel each other out, because if you have 2 halves, you have a 1. They're both negative, so that makes it positive. So I end up with y equals, and negative 2 times a negative 3 is going to be a positive 6. And then negative 2 times positive 2 is going to be a negative 4. So we're going to start at 4. 1, 2, 3, 4, negative 4. So our m value is 6 over 1. Our b value is at negative 4. We have a positive slope, so we know this line is going to go up when reading from left to right. So here at negative 4, we're going to go up 6 over 1. And then we've probably maxed that guy out. So I would say draw the line as straight as possible. Give me some arrows on the end, and you've got that one graphed as well. All right, guys, that's it for today. Have a fantastic afternoon.